You have decided to put cells of lithium iron phosphate on the boat and are thinking where to start, where to buy batteries, how to choose them, how to connect it with your old equipment. Do not hurry. After all, you missed the most important thing. The most important thing is a topology of the electricity storage network, and we will talk about this now. Welcome to the channel, Paradise Workshop. Even if you are not a technical person, even if you do not assemble and install lithium on the boat yourself, you definitely need to know about the topology of the electricity storage network, since it will depend on this in the future. How all network components and external participants in the electrical system work with each other. What will happen if the equipment fails, and how to prevent the effect of falling dominoes when the failure of one node entails the inevitable death of others, and the associated advantages and disadvantages of the options. Under the term topology, in this video, we are primarily looking at the physical structure of a boat's power storage network, for our application task of making our boat autonomous, or completely off-grid. So, let's talk about the two most common topologies and the advantages and disadvantages of each. By feature set, we can divide these two topologies into smart interactive and online. Smart interactive is a network controlled by BMS, where LFP cells are connected to the battery management system. Solar chargers, inverters, a shore charger and alternators are also connected via a dedicated controller to the same BMS. In this case, the main advantage is the overall synchronization of the entire system. Why is synchronization so important? A boat is a set of chargers working in parallel. As a rule, modern chargers use the same three-stage charging algorithm. First, the batteries are charged to the required voltage with the maximum possible current. Then, they switch to the absorption mode, when the charging current gradually drops and the voltage remains at the same level. Just at this moment, it is ideal to start balancing the cells in parallel. And then, the transition to the float mode follows. This mode, in the case of lead-acid batteries, is self-discharge compensation due to the chemistry. And in the case of LFP cells, it is simply a voltage set below the restive voltage. If independent chargers are not synchronized, then each charger operates according to its own internal program. And even if the settings indicate the same voltage values for switching to absorption and float modes, the chargers can actually work differently. Why does this happen? Calibration for all devices is at least slightly different. Most often, chargers do not have separate V-sense measuring wires, and each of the chargers measures the battery voltage via the same wires that are used to charge. And the length and cross-section of the power cables, and accordingly the voltage drop when measured, are different for all chargers. These and other reasons lead to the fact that chargers can be in different modes at the same time. For example, the transition voltage to the absorption mode is 3.45 volts per cell, and 3.45 volts is the start point for the cell balancing mode. One of the chargers has switched to absorption mode, and the second is still in bulk mode. Charging current is still high and the balancing process is not effective. Often, an additional benefit of the smart interactive topology and the central BMS is the control of the emergency shutdown logic of the chargers. For example, if the BMS turns off the battery while it is being charged by the alternator, a sharp rise in voltage will occur, and the diode bridge of the alternator may be destroyed. And here it is critical firstly disconnect the charger, and only then physically disconnect the battery. All this is also carried out by the logic of the central BMS. In the smart interactive topology, all chargers and all compatible consumers, such as inverters, forget about their internal programs and only follow the commands of the central BMS. They simultaneously switch to the same modes, and if necessary, their operation can be blocked by the logic of BMS. Let's talk about security and fault tolerance of the electricity storage network. This is a very important point, since electricity is used on a boat, often far from the shore. Smart Interactive is usually a topology, where a BMS, being the central point of the system, is connected to one large battery. And although LFP cells are quite reliable, there is a possibility of damage. And there is also a possibility of failure of the central BMS itself. In this case, physical actions will be required from the system user. For example, switching to an alternate path, bypassing the BMS contactor relay, if the additional path was created in advance when designing the system. In this case, all chargers can turn on their internal charging algorithms. If the balancing function was a part of the central BMS, then balancing will not be available. When using independent balancers, the function will be available. The best option for the Smart Interactive topology is definitely to have a spare BMS on the shelf. To prevent an electrical blackout situation, due to one cell failing, it is optimal to use high-quality cells and use a 2P4S connection for 12-volt systems. In this case, it is physically possible to use 4 cells out of 8, losing just half the battery capacity. Now, let's talk about the online topology, in terms of synchronization and general logic. There is no central BMS. Each set of cells is controlled by its own battery management system. Depending on the task, the cells in the set are connected in series or in parallel. Each of the sets is an independent battery, connected to a DC bus. Most often, on boats, batteries are connected to the DC bus in parallel to increase capacity. Chargers and consumers consider all sets of cells connected in parallel to the DC bus bar as one large battery. Synchronization of chargers using BMS is impossible due to the lack of centralization. And with proper system design, it can only be done in a passive way, using cables of equal cross-section and length. Some equipment manufacturers offer the option of synchronizing chargers in the form of combining them into a network, together with vSense devices. The main advantage of the online topology is the ability to build a network with high fault tolerance due to battery redundancy. Since all sets of cells are independent, if one or more batteries fail, the operation of the system is not interrupted. This is especially important in life support situations on a boat at sea. But, creating such a system, you must think about such an important point as the correct distribution of current within an electricity storage network, consisting of parallel batteries. In addition, since the fault tolerance of a service battery consisting of multiple sets of cells is organized through redundancy n+1, for example, the maximum current in the system should not exceed the maximum current for n batteries. Otherwise, the failure of one battery will inevitably lead to the death of the others. The efficiency of your boat's electrical system starts with its design. Pay maximum attention to the boat's engineering systems when switching to lithium batteries. Subscribe to the channel and don't miss the next videos. Thank you for watching.